Now I had told you that I would prove it mathematically that while ray is traveling from rarer to denser, it has to bend towards the normal. See, let us prove that. This is angle of incidence I, this is angle of incidence R, and if I have to prove that light has bent towards the normal, angle of refraction should be less than the angle of incident, right? So what we are going to do, consider this light ray is going from medium 1, so here refractive index is mu1 and refractive index is mu2, from mu1 to mu2, where we have given the statement that mu2 is greater than mu1, that means light is traveling from a denser to rarer medium. It's going from rarer to denser medium, but I have written to both the ways. Now it is clear that light rays mu1 is less than mu2, that means light is going from a rarer to denser medium. Okay, now according to Snell's law, I am talking about interface 1. This is my first interface. So I'll use the board in two halves, and for interface 1, what do we have? According to Snell's law, how do we use Snell's law? We always use Snell's law like this: sine I over sine R is equal to what? Mu, not just mu, either it has to be 1 mu 2 or it has to be 2 mu 1. What would be in this case interface 1? The light is traveling from 1 to 2, that means it would be 1 mu 2, which is further written as mu 2 over mu 1, right? This means sine I upon sine R is equal to mu 2 over mu 1. Which one is greater out of mu 2 and mu 1? Mu 2 is greater than mu 1, that means the division will be greater than 1. So here we'll use the inequality thing. Sin I upon sin R is greater than 1. That means what? Sin I is greater than sin R, and that means what? I is greater than R. So if R is less than I, that automatically means that what? That light has bent towards the normal, not away, because if it would have been away, the angle R would have been greater than I, right? So similarly, the converse of this you guys can do on your own. Just pause the video right now and do for what is this, for second interface, right? I am doing though for you guys, but just pause the video right now and try to do it on your own and then match the steps, okay? Now, according to Snell's law, don't use abbreviations or small parts like this. You guys are supposed to write in complete. I can save my time by doing that. So, according to Snell's law, sin I over sin R. Interface 2, this is my I, this is my R. If you want to further eliminate the confusion, use I1 or R1, okay? But I have written, okay, let's just do that. Let's just do I1 and R1, okay? So here I will be having sin I1 over R1 will be equal to what? No, it's not mu, it is either 2 mu 1 or 1 mu 2, and in case of interface 2, the light is going from medium 2 back to medium 1. That means you have 2 mu 1, and 2 mu 1 is what? It is mu 1 over mu 2. So sin I1 over sin R1 is equal to mu 1 over mu 2. That means this term is what? Mu 1 is less than mu 2, that means this whole division will be less than 1, not negative, less than 1. Sin I1 over sin R1 is less than 1. Sin I1 is less than sin R1, that means I1 is less than R1, or in other ways R1 is greater than I1. R1 is greater than I1, that obviously means that light has bent away from the normal, or the angle is more, alright. This is the mathematical proof of refraction.